Section 4.3 is equivalent fractions. So, equivalent fractions. To write equivalent fractions, multiply or divide the numerator, that's the top of a fraction, and the denominator, that's the bottom, by the same non-zero number. In other words, for all numbers a, b, and c, where b does not equal 0 and c does not equal 0, we have to say that because since b and c are in the denominators, we cannot divide by 0. So you cannot have a 0 in the bottom of a fraction. So for all numbers a, b, and c, if I start with ab and I multiply the top and the bottom by the same number, I will get a new fraction that is equivalent to the first fraction. Same holds true when I divide the top and the bottom by the same number. Again, I get an equivalent fraction. So let's look at this and see how it works. So here's one example. If I start with 1/3 and I take that fraction and multiply it by 2 over 2. In other words, multiply the top by 2 and multiply the bottom by 2. When I get my answer, 1 times 2 is 2, 3 times 2 is 6, this fraction is equivalent to 1/3. The same way I can take a fraction like 3/6. If I divide the top by 3 and divide the bottom by 3, 3 divided by 3 is 1, 6 divided by 3 is 2, and I get 1/2. Those are equivalent fractions. So let's try one. So the directions say to write two fractions that are equivalent to the given fraction. You can use multiplication or division. So 4/8. So I'm going to do this two different ways. I'm going to start by multiplying. 4/8 is the same as 4 times, and I'm just going to pick any number. It really doesn't matter what you multiply by, because it's always going to give you an equivalent fraction. So 12/24. 4/8 and 12/24 are equivalent. We do one with division, and in this case we do want to divide by a number that goes into both of those evenly. So I'll divide both of them by 4. I could also have divided by 2. 4 divided by 4 is 1. 8 divided by 4 is 2. And I get 4/8 is equivalent to 1/2. Let's try another one, 3/5. And again, you can multiply, well, 3/5, not 3/4. You can multiply by whatever you want. I can't find my eraser. Well, okay. So you can multiply by whatever you want, and I am going to pick multiply by 2. And I'm going to write it a little differently. I'm going to multiply top and bottom by 2 still. Both of these things mean to multiply the top by 2 and the bottom by 2. And I'm going to get 6/10 for my answer. So let's do another. It says we have to write two fractions. However, when I look at this, I don't want to use division. I don't have a number that I can divide into both of those evenly. So division is not going to be my best choice here. So I'm going to do another multiplication. I'll do 3/5, and this time I'll multiply by 4. And this time I get 12/20. So 3/5 and 6/10 are equivalent, just as 3/5 and 12/20 are equivalent. Let's take a look at what we're really doing here. When I multiply by 2 over 2, or multiply by 4 over 4, or multiply by 3 over 3, I'm really multiplying by an equivalent to 1. And we all know that if we multiply by 1, we get something that is still equal to what I started with. So these two are equal, they're just in a different form. But by multiplying by the same on the top and bottom, we're not changing the value. 3/5 is equal in value to 12/20. We're just changing the way it looks. Okay? So, simplest form. In order to make a fraction in simplest form, we have to make sure its numerator and denominator are relatively prime. So, write the following fraction in simplest form. 12/30. I want to simplify this, and I'm going to use division to make it smaller so that 12 and 30 are relatively prime. And I'm going to divide the numerator and the denominator by the greatest common factor. So the greatest common factor of 12 and 30 is 6. Divide by 6, divide by 6, and I get 2/5. 2/5 is equivalent to 12/30, but it's in simplest form because 2 and 5 are relatively prime. They don't have any more factors in common. What about 36/64? Well, I'm not sure what the greatest common factor is. Now, I could go over here and do my factor trees for both of them and get my greatest common factor, but I'm just going to divide by 2. I know that 2 goes into both of those, and I get 18/32. Oh, that's not relatively prime. I know that 2 will go into those again, and that will get me 9/16. So I've divided twice. 9 and 16 are relatively prime. The factors of 9 are 3 and 3. The factors of 16 are 4 2s. No common factors, so relatively prime. So 9/16 is my simplest form of the fraction. Now, if I had known that 4 was the greatest common factor of 36 and 64, I would have gotten 9/16 also in one step instead of 2. But either way, as long as we get down to the point where we have the fraction that is equivalent, but in simplest form, meaning nothing else will divide both of those, then we are done. The last thing we want to look at is variable expressions. Now, when we simplify a variable expression, we're going to first write the factors out. The factors of 10 are 5 times 2 times x times y. That makes my xy. The factors of 15 are 5 times 3 times y times y. And what I'm going to do here is I'm going to cancel out the common factors. 5/5 is 1, so that will not change my value. Y/y is 1, and I'm left with 2x over 3y. Now you could use this same thing with just numbers. Let's go back to our 12/30. Instead of saying 12 divided by 6 and 30 divided by 6 to get 2/5, I could have taken my 12/30 and written it as factors. The factors of 12 are 6 times 2. The factors of 30 are 6 times 5. If I divide the top and bottom by 6, I'm getting rid of the 6's, and I get 2/5. So both of these methods are good for numbers, but this is the method we always want to use when we have variables. Let's try one more. So the factors of 32. Well, I happen to know that 32 is 16 times 2. So I'm going to use that because I have a 16 in the bottom that I can cross off. X cubed is x times x times x, and then I do have a y there. At the bottom, I left my 16 whole because I can already cancel those out. I have 4 x's, 2 z's, and 1 y. So the 16's cancel, 3 of my x's will cancel, leaving 1 here, and my y's will cancel. So up top I'm left with a 2. On the bottom I'm left with 1 x and 2 z's. And that's my simplest fraction. That's it for now, so I'll see you in class.